This next video is going to explain something that was in the last video that I kind of skimmed over, and it's this idea of set notation. So you'll notice in this last example, they gave all these numbers that we were classifying in these squiggly brackets. And so this is called a set. So it's a set of numbers, and it just sort of, defines what you're looking at. So we're going to look at that a little bit closer. So writing sets using set notation, a set can simply be the braces, right? They're called set braces, and they're used to enclose the elements of, whatever it is you're looking at. So for example, we've got this example here. We've got the set of numbers 1, 2, 3, and it's the set containing the first three counting numbers. Or we could say, hey, our set is some natural numbers. So capital N is defining the set 1, 2, 3. So then we could, use an N somewhere else, and we wouldn't have to write the set 1, 2, 3. It could represent it. And then this textbook kind of goes a bit further, and they have this really proper notation, which is called set builder notation. And set builder notation is used when you're when a variable is used and you're trying to define the variable. So for example, we're going to take a linear equation, something like x plus 3 equals 5. And then we're going to subtract 3 from both sides, and we're going to get x is equal to 2. Now, I could leave my answer like that and be like, yep, x equals 2, I'm done, full marks. And the textbook often will do that too. But sometimes the textbook will go a bit further. And they'll say, hey, I'm really bad at drawing these brackets, just FYI. The answer is the set of 2. So sometimes they'll set the brackets around it. Sometimes they'll go even further, and they use what's called the set builder notation. So they'll say that the answer is the set of x, so they'll show you what you're solving for, such that, so they do this like line that is meaning such that, and they would put something like x is equal to 2, right? And that would be a very formal answer. So I mean, this is great. This is a step up. This is like a very formal way of presenting a solution. And sometimes the textbook does that. So this section is just getting you used to seeing it so that you can kind of see beyond it and just be like, oh, okay, the answer's 2, sweet, right? You can kind of ignore the rest. But it is good to know. So the brackets are red, the set of. The line is red, or sorry, the x is all elements of x is defining what you're solving for. The line means such that, and then you'll say that x is something. Okay, so x has property p. All right, so the next thing is just understanding that there's 3 types of sets that you can get as an answer. There's a finite set where it's like, okay, you're counting numbers from 1 to 3. 1, 2, 3 would be the set. Whereas an infinite set would be like, what are your counting numbers? Well, you'd be like, 1, 2, 3, dot, 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 right? They'd keep going on and on forever. The third type is called an empty or a null set, and that's when there's no elements in the set. So to show that, we can give empty set brackets, right? We can just be like, nope, there's no solution. Look, there's nothing inside. Or, because mathematicians are lazy and these brackets are sometimes hard to draw, sometimes people will just do this, which is called your null sign, right? This means no solutions. And so there's just different ways of representing solutions, and this section is just showing you all the different ways so that when you look at the back of the book for your answers, you're not like, what are they saying there? So here's some examples of questions you could be asked. The first one is, list the elements in each set. Okay, so it's the set of x such that x is a whole number less than 4. Now again, cart before the horse, right? We are going to talk about inequalities coming up, but hopefully you do have some idea that less than means numbers that are smaller than 4. So this wants me to list all the elements that are whole numbers less than 4. So I'm going to show it in a set bracket. And what are some numbers less than 4? Well, not 4, because that'd be less than or equal to 4. So we'll do 3 and 2 and 1 and 0. Is there an end? Does it keep going to the left? No, because then we'd be going into the integer stream. So the only numbers that are whole that are less than 4 are 0, 1, 2, 3. What about this one? This is the set of x such that x is a whole number greater than 4. Can you pause the video? Can you figure out what this set would look like? So what are the set of numbers that are whole that are greater than 4? Well, we can't do 4 because that'd be greater than or equal to 4. So let's start at 5, and then 6, and then 7, and then dot, dot, dot. There is no end. Whole numbers go up forever. They just can't go down forever. So this first one would be an example of a finite set. This second one would be an example of an infinite set. The last one is the set of P, such that P is the days of the week that start with the letter P. Well, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, there's no day of the week that starts with the letter P. So there are none. You can do a null sign, or you could draw empty set brackets if you like them, or you want to practice them. The only other piece of language that I want to talk about is this E. It's called an epsilon. And again, math uses symbols to represent words, right? They're too lazy to say that, X is a member of this set or something along those lines. So instead, they use symbols. So E means that it is a member of, and E with a line through it means it's not a member of, just like equals versus not equals to, right? We put a slash through it, meaning nope. So let's look at an example. So for example, over here, we've got the set A. A is defined as the set of numbers 1, 2, 3, 4, 5, 6. So 6 is an element of the set A, where 7 is not an element of the set A. So now how about these questions? Is 3 an element of the set 1, 2, 3, or is it not an element? Now I'm saying element, sorry. It doesn't really matter what you say. This, technically we should say member, but other textbooks call it an element of. So if you're wondering why I'm switching my words, it doesn't really matter. Okay, so the question is 3 in this set? Yes or no? If it's a yes, use the E. If it's a no, put an E with a line through it. So the answer is yes. 3 is a member of the set 1, 2, 3. What about 6? Is 6 a member of the set 1, 2, 3? No. All right. And then really, where's this going to matter? Not this, right? This was just a way of combining the two things. What's going to matter in this course is that we're going to talk about this statement here. My question is, after these two objectives, could you read that to me? Take the symbols and translate them into words. This would be X, that's simple, is a member of, what was the R? Do you remember? The real number system. Now, those of you who have taken math semi-recently might know that this is used when we talk about the domain of something where X could be anything, right? We're like, X could be anything from negative infinity up to positive infinity. Then we could say X is a member of the real number system, right? X is anything as long as it's real. So just kind of linking the words to something you might relate it to make it review. But for some of you, this might be new language, and that's okay too. All right, go practice this little section and come back and watch the next video.